So in this video, we're going to look at the effect of the beam symmetry. So beam symmetry is an important clinical property for radiotherapy beams because we want our beams to be flat and symmetric. So what I have here is I have our 6 MV beam loaded, and I've got the improved flattening filter for the 6 MV beam. So we can see this in our analysis tab for SIMAC, where we see our nice flat beams. So what SIMAC has is a feature by which we can explore the effect of beam symmetry when we have an imperfect beam. So over here we have steering coils, but we also have over here we have gun errors. So we have a radial gun error and a transverse gun error. So what can happen to a beam, a clinical beam, is that if the electron beam from the gun is not centered perfectly, what will happen is the electron can end up on the target in the wrong position, and it'll end up producing a beam which is not flat. And we kind of showed this schematically here on the main SIMAC screen. So to illustrate this, what I'm going to do is I'm going to introduce a radial gun error of just a small amount. I'm just going to make this a little bit, say, something like 0.03 millimeters. So when we do this, what this means is that in the radial direction, the beam emerging from the gun is offset just a little bit, and this can happen for a number of reasons within a gun. And so now when we look at our analysis tab, what we see is that the beam is a little bit not perfectly flat. So it's kind of a little more intense on over here on the right side and in the radial direction than it is over here on the left side. So we can make that even bigger by increasing this still a little bit further. And now we can see that effect amplified a little bit more. So now we have a beam which is unflat. So this here, so we have what SIMAC does, it also calculates the value for symmetry. So the value of symmetry is 3.89. And so what it does is by essentially comparing this side of the beam versus that side of the beam, it does this using a standard symmetry calculation that's used for most symmetry measurements on clinical linear accelerators. So this is the value that we'd like to improve this beam. So how we can do this by steering the beam back towards the center of the target. So what I'm going to do now, so I know I've adjusted the radial gun error, and we've validated that by doing our profiles and seeing that the beam is not symmetric in the radial direction. So again, we have 3 sets of coils. We have the radial coil, we have the buncher coil, and we have the angle coil. These are which are the normal coils in a variant style linear accelerator. So what I'll do is I'll start by I'll increase this number here to say, I'll make this say 50 milliamps going through the radial position coil. So when I do that, now we've steered this a little bit. We go back to our analysis tab and we can see, and now it looks like my symmetry is worse. So before it was in the 3s, if I remember, now I've made it 6, almost 7. So I've gone the wrong direction. So what I can do is I can come back here and I can now make this negative. So I'll make that negative 50 instead of 50. And what we have now is on the analysis tab is we have a beam which is flat. So that is, we can turn our symmetries back down again. I can see if I can make that a little better. Maybe I'll make that a little bit, slightly, increase that number a little bit, say minus 70, see what we get on our analysis. So now we have, looks like it's gone a little too far the other way, so minus 50 was probably about right. So I'm going to increase this back, so let's try minus 60. And minus 60 is producing a symmetry 1.24. So this is probably minus 60 minus 50 seems to produce about the same number. So this is how SIMAC can investigate the symmetry problems with beams. We can simulate a beam error, then we can see how we can correct it. Now, just to see the effect, is if we see what would happen if we had no beam error, but we still had a radial steering current applied. So I can decrease this back again to 0. So I can remove the gun error, and then we can have a look to see what happens with the beam in that case. So I'll go back to 0. And now our beam on the analysis tab is showing that it's asymmetric again. Now it's higher on the left side than it is on the right side, which is what you'd expect. Now we correct that by removing the radial gun current, the radial coil current, and we now have our flat beam again. So this is the other property, clinical property that we can explore in SIMAC. So the property of symmetry. So we saw in previous videos that the beam energy can affect the beam flatness, and we can change the beam energy in a number of ways, and we can also adjust the flattening filter. But we can also have symmetry errors as a result of gun problems. Now, gun problems happen mainly as guns age, and the electron emissivity from the gun surface can change due to the aging of the gun, and that can lead to gun not being perfectly symmetric. And then, as we see in this example here, that leads to an asymmetric beam.